Okay, so when you think Romania, maybe your first thought is Dracula, old castles, that kind of thing.
Right, the classic images.
But what if I told you there's something there, something natural that's actually, well, stranger than myth, something that really makes you rethink things?
You're talking about the Trovants, I assume.
Exactly. Trovants, these stones that apparently grow and move and even, well, multiply.
Yeah, you heard that right. Rocks behaving like living things. It's pretty unique.
It really is. It kind of turns geology on its head, doesn't it?
It does. And that's sort of the paradox we want to get into today, right?
Yeah.
In this deep dive, we're going to look at the science, the theories, and honestly, the mysteries that still surround them, using what we found in the source material, of course.
Yeah, trying to figure out how something that seems so inert, like a stone, can act so well alive.
That's the core question. How is this possible?
It feels like the ultimate riddle. Lifeless rock mimicking life. So yeah, let's unpack this. Where do we even start? Where are these things?
Okay, so they're mostly found in southern Romania. There's a specific village, Casteti.
Casteti, right.
It's kind of ground zero. They're so important there, they actually have a dedicated museum, the Trovant Museum Natural Reserve.
A museum for rocks.
Well, for
Wow.
these specific rocks, yeah. It's been a protected site since 2004, apparently safeguarding some of the biggest ones.
And the name Trovant.
It
That tells us something too, right? It's Romanian.
is. It comes from a naturalist, George Munceanu Mărgocii, and it's basically a synonym for a German term.
Ah, the sandstein concretion.
Exactly. Which just means sandstone concretion.
Okay, so sandstone concretion, what does that actually mean in simple terms?
It's essentially, sand and bits of rock all stuck together, cemented naturally over time by minerals. Think of it like nature's concrete.
Gotcha. But what makes Trovant special then? Just being concretions?
Well, it's their appearance partly. They often start out really smooth, no edges, kind of round or nodular, sometimes almost perfect spheres. But then, as they supposedly grow and multiply, they can get these really inconsistent shapes, sometimes quite irregular.
Why is that?
The thinking is it's down to how that natural cement gets secreted. If it happens unevenly during formation or growth, you get these weird shapes.
Huh. And they vary hugely in size too, I read. Like from tiny pebbles.
Yeah, grams, small enough for your hand.
All the way up to massive boulders, 10 meters tall.
10 meters, yeah. It's pretty staggering for something described as a rock.
That's incredible. And the source mentioned something about the smaller ones growing faster, almost like kids.
That analogy did jump out, didn't it? It suggests maybe a nonlinear growth, faster accumulation of minerals in the early stages, perhaps?
Could be. And it gets weirder inside too. If you cut one open.
Ah, the rings.
Yeah, tree rings, right.
Yeah.
Spherical ellipsoidal patterns inside.
Exactly, which just adds to that feeling of something biological. It suggests a patterned, maybe cyclical internal development, not just random accumulation.
Mind-bending. Okay, so they grow, they have rings, but they also move. The source mentioned a study.
Right, the 14-day observation. They tracked one Trovant and recorded a shift.
2.5 millimeters. Okay, it's not exactly squinting,
No, definitely not.
but still, a rock moving on its own. How do scientists explain that if they're skeptical about, walking?
Well, that's the key. They are skeptical about self-propulsion. No one's saying the rock decided to go for a stroll.
Okay, right.
The main idea is external factors, the soil around it heating up and cooling down, rain making the ground swell or shift.
Ah, so the environment pushing it slightly.
Precisely. It's more about interaction with the environment, not the stone having its own intention to move.
That makes more sense.
Yeah.
But
yeah.
still, pretty active for a rock.
Yeah.
So all this activity, what about where they came from in the first place? The origins. Lots of theories there too, it seems.
Oh, yeah. Wind erosion, temperature changes over ages.
Water seeping into ancient sand, cementing things.
Even seismic shocks, maybe around 6 million years ago, causing sand to clump together.
So a lot of different ideas.
And that's where the scientific debate really heats up, because none of those theories seem to perfectly explain everything we see, especially the growth in, well, the budding we need to talk about.
Right, like wind erosion might explain smooth shapes, but not the internal rings.
Exactly. Or the growth. It pushes the boundaries of our geological models. In fact, some scientists are so puzzled they suggest maybe they aren't even true concretions. Pseudo-concretions, they call them.
Meaning improperly categorized.
Kind of. And adding to the puzzle, that 2008 International Geological Congress in Oslo, they tested Trovants.
And found.
Basically no mineral difference between the Trovants and the sand around them.
Seriously. That is weird, because don't concretions usually form around, like, a central bit, a nucleus?
Often, yes. But Trovants frequently lack that distinct core, makes their initial start really mysterious, and the cement holding them together usually carbonates, like calcium carbonate.
Which isn't typical for these kinds of formations.
Not always, no. So you've got all these conflicting ideas, these odd characteristics. Honestly, no one can definitively say this is how they formed.
Wow. Okay, so their very origin is a massive question mark. But even setting that aside, how do they actually do the growing and moving now?
Right. If the origin is debated, the mechanism for the ongoing stuff growth, movement geologists do have a more dominant theory for that.
Which is?
It's linked to what they call their mineralization property.
Okay.
Essentially, these stones are packed with mineral salts. Lots of them.
Uh-huh.
The theory goes, when it rains heavily, the water soaks in and kicks off a chemical reaction inside.
A reaction with the salts.
Exactly. It causes the minerals to crystallize and crucially expand. This creates internal pressure.
Ah, and that pressure pushes outwards, making it grow.
That's the idea. Makes the rock grow from the center out, expanding its edges. And this expansion might even help with the multiplication aspect.
Is it fast?
Well, the reported rate is something like 4 to 5 centimeters per 1,000 years.
Okay, so not exactly overnight growth.
Definitely not by our standards. But still, for a stone, it's measurable, observable growth.
That does sound like a plausible geological explanation for the growth and maybe even those tiny movements.
Yeah.
But then there's the other thing, the part that really sounds like science fiction.
You mean the breeding?
Yeah. The sources describe this process. When a trovant gets wet, part of it swells up, grows a little bump, and when that bump gets big enough, it just breaks off and forms a new baby trovant.
That's the description. A new stone, similar structure to the parent, but it develops its own nucleus.
That's wild.
It really is. You've hit the absolute core of the mystery. It's like inorganic budding, like a plant, but rock.
And scientists just don't know how.
Pretty much. That's the part that remains largely unexplained. We can sort of rationalize the growth and movement with geology and chemistry.
Right, the rain, the minerals.
But this apparent reproduction, it just doesn't fit neatly into any known inorganic process. It mimics life, but it isn't biological.
It's amazing how something so simple looking can be so scientifically baffling. And while they're most famous in Romania, they're not only there, right?
No, they're rare, but reports mention places like Russia, Siberia specifically, Wyoming in the U.S., even other spots in the Carpathian Mountains.
And people used to use them for building.
Yeah, building materials, even tombstones, apparently. But that's stopped now, thankfully. The Trovant Museum site is protected by UNESCO, ensuring they're kept safe for study.
Good. So just to recap then, we've got these Trovants. They grow, albeit slowly, through mineralization.
Yes.
They show subtle movement, likely due to environmental shifts.
Like that 2.5 millimeter observation, yeah.
And the most incredible part, they seem to bud off new baby Trovants.
Yeah.
Almost like an inorganic life form.
That's the summary. And it loops right back to that central enigma, doesn't it? Growth and movement have theories, maybe plausible ones linked to rain and soil changes.
But the breeding.
The breeding remains deeply mysterious. And remember those 2008 geological findings? No real difference between the stones and the sand.
Yeah, that just makes it harder to explain how they form and why they behave so differently.
Exactly. It deepens the puzzle of how something seemingly ordinary can act so, well, extraordinary.
It really makes you think. These stones, mostly in Romania but popping up elsewhere too, they genuinely challenge our basic ideas about geology, maybe even about what life itself means.
Absolutely. We've looked at stones that grow, that move, that even appear to bud almost like plants. What's so striking here is how Trovants really push the boundaries, you know? They stretch our definition of life.
Yeah.
And maybe that leaves a question for you, the listener, to think about. If something can seemingly reproduce and grow, but it isn't organic, what does that suggest about the fundamental nature of existence itself? What lines are we drawing, and are they in the right place?